Experiment 4 is about gravimetric analysis of barium sulfate. The objectives for experiment 4 are the following: to illustrate the techniques used in gravimetric analysis and to quantitatively determine the percent sulfate in an unknown. Experiment 4 is an introduction to the field of analytical chemistry, which deals with the separation, identification, and quantitation of chemical compounds. So when you're dealing with analytical chemistry, it answers the question, what is present and how much is present. Okay? Now, one method that is used in analytical chemistry is known as gravimetric analysis. So it's a technique through which the amount of an analyte or the ion being analyzed can be determined through the measurement of mass. So maybe the root word here is gravi, which is weight, right? Because there's another technique known as volumetric analysis, which we're going to deal with in experiment 5. Okay, so gravimetric analysis just describes a set of methods used in analytical chemistry for the quantitative determination of an analyte based on its mass. So in this experiment, you're going to determine, the sulfate in a given unknown by reacting it with barium 2 plus. So when barium 2 plus reacted with sulfate, based on the solubility rules in chapter 4, they will give a solid precipitate called barium sulfate. So through the amount of the barium sulfate here, you'll be able to determine how much sulfate do you have in your unknown. So if we follow the steps in gravimetric analysis, this is how it looks like. First, you accurately weigh a sample of the material to be analyzed. Then you dissolve the sample in a suitable solvent, and then you completely precipitate the desired component as a pure compound of precisely known composition, and then you're going to filter or separate the precipitate into a filter paper that leaves no ash when burned, and then you burn up the filter paper under conditions that will not alter the chemical composition of the precipitate, or will alter it in a precisely known fashion, and then weigh the known precipitate. So to put into perspective those steps in this experiment, so here's the procedure. So the first thing that you're going to do is you weigh by difference two samples of approximately 0.4 gram each to the nearest 0.1 milligram. Then you place each into marked 250 ml beakers. Okay? And then you add 150 ml of distilled water and 3 ml of 6 molar HCl to each beaker, and then heat almost to boiling point, but do not boil the samples. And then you count the drops. You're going to add 0.5 molar barium chloride, okay, from a dropper until precipitation appears to be complete. So when you say complete precipitation, when you add a precipitating agent, okay, there's no more solid that is formed. Now, the way that you're going to do it is, if you add and you see cloudiness, so that means you still need to add more barium chloride. So barium chloride is the source of your barium ion. Okay, so the barium ion will react with the sulfate in your sample, and you're going to form the barium sulfate. And then use a small flame to keep the solution just below the boiling temperatures. You digest the sample for 40 minutes. So when you do digestion, it helps you give purer and larger crystals. Okay, and then after 40 minutes, you check it for complete precipitation by adding some drops of barium chloride. Now, while you're doing this digestion, you can set up two panels and put them with properly folded ashless filter paper. Okay, so once you test them for complete precipitation, you can decant each sample supernatant liquid through the ashless filter paper in the funnel setup. Okay? And then you're going to wash your precipitate several times with 2 to 5 ml of distilled water. And using a rubber policeman, you transfer all precipitate quantitatively, okay, to the filter paper. Now when you transfer it, you add some distilled water to it and test for chloride ions using silver nitrate. So the way that it happens is there's some chloride ion that's still there because you added barium chloride earlier. So by washing it, you're removing your chloride. So if you add silver nitrate and a precipitate it forms, that means chloride is still there, because your silver ion will react with chloride ion to give you silver chloride. And then, okay, maybe before you did this experiment, or you did this what we call filtration, you can wash, heat, and weigh 2 crucibles. Now once you drain the filter paper that contains now the precipitate, you transfer it, okay, in the crucible. And then you dry and char the filter paper with the precipitate in crucible. So the way that you're going to what we could do it is, you're going to put your crucible and its cover on a clay triangle in a slanted position, and then you hit it with a small plane, impinging the middle of the crucible's underside. So take your time, okay, do not hurry the drying by using too hot a plane. When the paper is dry, lift the cover slightly using the tongs, not your hand, okay. So this allows access to air and increase the heat to char the paper, so moving the flame toward the bottom of the crucible. So you must allow the paper, you must not allow the paper to burst into flame, because if that happens, some of your precipitate might be swept up by the escaping gas. Okay, so whenever you see a flame, immediately close the cover to smatter the flames, and take care that complete combustion occurs. Okay, so your flame should be blue, not yellow, because you want the reducing gases not swept back into the precipitate. So when you properly charred the paper completely, you remove the cover from the crucible and increase the heat gradually, okay, until the bottom of the crucible is a dull red. So it may be necessary to rotate the crucible from time to time, and when the dark organic material has completely burned away, set the crucible upright and continue heating with the hot display for 10 minutes. And then you cool it, okay, and then weigh the content. So you have to be sure that all the time you're using tongs in these steps. Assuming this is the data set that you have, okay, so in the lab report I already put some data and they look like this with some blanks. So how are we going to supply the blanks, and how do we do the calculation? So for instance here, okay, how do we know the weight of the sample? So it's just a weighing by difference, 1 minus 2, okay. So 17.3432, that's the weight of bile before you remove the sample, and then you remove some sample, okay, the remaining weight is 16.9313. So if we're going to do difference here, this minus this one, so you will get around 0.4199. Now at the end, you're going to get the weight of the crucible, which is 23.7431, and then the weight of the crucible with dry precipitate. So this is much higher compared to this. All you need to do is this minus this one, which will give you around 0.591. Okay, now the other step that we have here is will be given in the next slide, sample calculation. And for the value that we have here, you just get the average of these and these values here. So you're given 2 trials in your lab report. Okay. So in the sample calculation, the one that you need to show is at least one calculation of the calculated weight of the sulfate and the percentage of sulfate in the sample. So based on our process data, if we want to get the calculated weight of your sulfate, so we get the calculated data that we have there, that's what, 0.91. Okay, and then we multiply it with 96.1. Now where did I get this 96.1? That's the molar mass of your sulfate, and I'm going to divide it with this number. Okay, 233.0. Both of these are in grams. Okay, now this corresponds to what? The molar mass of your barium sulfate. So if we do the calculation here, you get around 0.2438. I think it's around 0.2437 something, but when you round it up, you got 0.2438. So that is the calculations for the calculated weight of sulfate. Now after we get that one, we can get the percent sulfate in your sample. Okay, so we get that value 0.2438 and divide it with the mass of the sample that we use, which in this case in the sample calculation is 0.4119 gram. Okay, and then we multiply that with 100 because you ask the percentage, and you're going to get 59.18% at least for the given data. So for the lab report here, you just need to supply the missing data, show some sample calculation, and answer the questions that you have at the end of the report. Okay.